All right, number 7. There is a lot of language going on here. I had to read it 3 or 4 times, but here's what I can tell you. The volume of this trough is the same as taking the volume of a triangle prism. It's a triangle with depth. I'm going to say like front to back depth. So the volume of this is 1/2 W times L times H. Okay, now, if you read all this, it says that the trough is 10 meters long. And it doesn't matter how much water is in this trough. It could be a third of the way, a quarter of the way, a half of the way, all the way. L is not changing. This letter is not changing. And since DL, I'm going to write this down, DL is 0, I can go up to my formula and can rewrite this as 10. So right now, I have 5WH. If I differentiate that right now, it would be a product rule. It'd be 5WDH plus H 5DW. Now, this is kind of like a cone in the fact that if I draw a line right here, this little isosceles triangle is similar to if I draw a line right here and color in that one. The small one and the bigger one, as water fills, it's like a cone in the fact that there's a ratio connecting W and H. So let's read. It says the width is 4 and the height is 5. So that means the width is 4/5 the height. And that will always be true. Always be true because of the design of this three-dimensional solid. So what I can do is I can take this and I can sub it in for W. So if I do that, it would be 4/5 H times H. And that 5 knocks out that 5. So really the volume of this trough at all times is 4H squared. Now let's differentiate. dV dt equals 8H dH dt. That is a very clean differential equation. If you look at what it says, it wants to know dH when it's 1 meter high for a height and 3 meters high for a height. It also tells you that dV dt is 3 and it's positive. So here's what we need to do. At 1 equals H, and we have to do it at 3 equals H. 2 different times and compare. So here we go. dV dt equals 8 times 1 dH dt. If I divide by 8, I get 3/8. That's about 0.375. And this would be in meters per second. If I'm at 3, dV dt equals 8 times 3 dH dt. You get 3/24, and that reduces to 1/8. Again, that is in meters per second. So when we compare and contrast, you can see that when the height of the water is 3, the rate the water is filling and rising the height is not as much as it was earlier. Now the last part of this question is to actually find the difference in the rates. So to answer the question, I'm just going to literally take 3/8 and subtract 1/8, and the answer to this question is 1/4, and that is in meters per second.